Welcome back to Low Stress Math with Mrs. Bono. We're still on Chapter 1, Exponents, and we're going to page 19, which is Independent Practice for Lesson 4, the Product Rule. You can see right here that there is a QR code, and that's going to give you a video that will help you, but it's not one of my videos. It's a different point of view. So if my videos are not helping you, you can use that QR code to try a different way to do it. Well, it's the same way to do it, but it's a different explanation. So let's get started. You turn off the video and you try these problems. There's only 14 of them. Some of them you can use your calculator for, but I think you can do most of them. When you come back, we're going to go over it. All right, welcome back. So let's read the directions. I know it's not anyone's favorite part, but right here it says expand and simplify each expression. Do not evaluate. So I'm just going to highlight this word expand. And when I expand, I am going to expand the first in blue and the second one in pink. So a squared is a times a. And I'm multiplying that, times a cubed. So a cubed is a times a times a. My base does not change. It stays a. So base a. And how many times did I use a as a factor? 1, 2, 3, 4, 5. I used a as a factor 5 times, so my answer is a to the 5th power. And I'm going to put a little box around that because I can't even evaluate it. It's not a number, but I did simplify it. When I say simplify, this is what I mean, a base and an exponent. When I say expand, that's this part where you show what each one of the factors are. The next one, b cubed times b to the 4th. Again, I'm going to do the first term, b cubed, in blue, and that's b times b times b. I'm going to do the second term in pink, b to the 4th power, b times b times b times b. Now the base is b. The base is not going to change. The the product rule of powers says keep the base b. And let's add these exponents. 3 plus 4 is 7. 1, 2, 3, 4, 5, 6, 7. That's right. The exponent is 7. So b to the 7th power. And I'm putting a little box around there because that's the simplified version of this. Now down here, I could actually evaluate this, but I'm not gonna because the directions say don't evaluate it. And the first term is 2 cubed. So in blue again, 2 times 2 times 2. And the second term is 2 squared, 2 times 2. I keep the base 2. Now you can either add 2 plus 3 and get 5, or count 2, 2, 2, 2, 2. 2 was used as a factor 5 times. All right. And I want to solve that so bad, but I'm not going to. No solving things when it tells you not to. All right. 5 squared, 5 times 5, and 5 to the 4th power, 5 times 5 times 5 times 5. I keep the base 5, and I can either add the exponents, 2 plus 4 is 6, or count how many factors, 1, 2, 3, 4, 5, 6. So 5 was used as a factor 6 times. That's where that exponent's going to come from. Okay. Be careful when you write something in exponential notation. You want to make sure that you can clearly tell what the base is and what the exponent is. I noticed some of your work, you have a little problem with that. And it's not such a bad problem when you have a variable with an exponent. But if you have a 2 as your base and 5 as your exponent, and you're not careful, it could end up looking like 25. So just remember, try to be careful when you're writing. Make a big base and small and up to the right exponent. All right, the next one. Use the product rule to simplify each expression. Again, do not evaluate. Now, here's how you show work. Remember, we talked about this. You write the base. So in this case, the base is r. And then you add the exponents. 2 plus 4 plus 5. So you have the base does not change, still r, but 2 plus 4 is 6, 6 plus 5 is 11. So I have the base r and the exponent 11. Right? For the next one, I don't have an exponent, but I can put my own. Remember, I told you, there's invisible exponents. If you don't see the exponent, you can put your own. And there's 1m here, so I'm going to use the exponent 1. Still, don't change the base. Keep the base m. But now you're going to add the exponent 2 plus 1. And I get m to the third power. And I forgot to change pens, but that's okay. For this one, again, I don't have an exponent. So I'm going to put a 1 there, x to the first power. Remember, keep the base, add the exponents. 1 plus 16. So keep the base x, and 1 plus 16 is 17. So I'm going to have x to the 17th power. I put lines through my 7s sometimes. It's just a habit. I don't know why I really do it, but I think it looks nice. But yeah. All right, the next one. Keep the base 2 and add the exponents 14 plus 15. So 14 plus 15. Nothing is happening to the base. The base has not changed once. Keep the base 2, and now my exponent is 29. I would not want to evaluate that one because that exponent is too big for me. And I forgot my equal sign. All right. For 9 and 10, circle true or false and tell whether each statement is true or false. If it's false, make the sentence correct. Okay, let's take a look at number 9. For this one, I'm going to make it a little bit bigger because I think it'll be easier to see. So let me move this over here. Come on, just there we go. And for this one, I keep the base 10. 3 plus 4 is 7. Oh, that's the answer they have. That is true. And for this one, the base is 2, and 2 plus 4, the base is 2. The exponents are 4 and 2. 4 plus 2 is 6, not 8. So this is false. Keep the base and add the exponents 4 plus 2 to get 2 to the 6th power. Now, it says make the sentence correct. That's the sentence. If you wanted to write this, 2 to the 4th power times 2 squared equals 2 to the 4 plus 2 equals 2 to the 6th. That would be fine too. Either of those, good. Got to show some work though. Right down here, it says, perform the following operations and try it without a calculator. Now, this is not always easy because you got to remember the laws. Here we go, the rules. In addition, when the signs are the same, you add the numbers. 10 plus 6 is 16, and you keep the sign. So it's negative 16. So 9 minus 15. I'm going to rewrite that as 9 plus negative 15. Signs are different, so I subtract. 15 minus 9 is 6. But 15 has the larger absolute value, and it's negative. In other words, 15 is more negative than 9 is positive. So I think of it as money. I have $9. I owe somebody $15. I still owe them $6 after I pay them up. So I'm still kind of in debt here. In this one, completely different rules for multiplication and division. In multiplication and division, you multiply or divide the numbers. So in this case, I'm multiplying the numbers. 8 times 5 is 40. And when the signs are the same, the answer is positive. But if the signs are different, the answer is negative. So over here, the signs are different. So the answer is negative. And 200 divided by 50 is 4. So it's negative 4. So with addition, same signs, keep the sign. Change subtraction to add the opposite, and then follow the rules for addition. For multiplication, same signs positive, different signs negative. And for division, same thing. Same signs positive, different signs negative. Well, that wasn't so bad. Good luck, and we will do some more math tomorrow. Bye.